Right, so after we have locate all of the diffusers inside our layout, okay, now I will relabel again all of the diffuser. We have 16 diffuser. Okay, the length between the diffusers must be known in order to check the throw radius. Is it enough or not? Okay, so first we have XT divided by X section just now. So XT divided by X, we have 10 feet here. Okay, and also on the upper side we have 18 divided by 8, so it becomes 10 feet also. Okay, so this is also 10 feet. Okay, so from the question it already mentioned that the throw radius is 12 feet. Okay, it means that all of the diffusers can throw only 12 feet. So if our section is higher than 12 feet, so that is not enough. So in our case, all of the diffuser throw more than the section, so it should be enough, and this design is okay, so no need to modify. Now the next step is to construct the table in order to calculate the friction of the ducting system. Okay, so first we need to label of the all of the section. Okay, I label with green color. So this is the origin O, this is A, this is B, this is C, this is D. Okay, so this point basically is the main point which spread the air into the branch ducting. This is branch ducting, this is branch ducting, this is another branch ducting. Okay, same goes for the remaining section. Right, so the total CFM 6400 from the FCU is distributed to the main ducting first here, O, A, B, B, C, and C, D. So here all of the air have a volume flow rate of 6400, and then once it pass through the first row here, first 4 row, it will minus another 400 multiplied with 4, which is total is 1600 CFM. So the remaining air flow rate here is 6400 minus 1600, so we get 4800 CFM only. Okay, so on the AB section the CFM become 4800, and then the next section also we minus with 1600, becomes 3200, and the last one 1600 CFM is shared between the 4 diffusers. So that is all the main duct. For the branch duct A to A1, okay, A to A2, okay, all of these diffuser must have 400 CFM. So from 6400 it will throw 400 CFM here, and then it will throw 400 CFM here. So same goes for A2. Sorry, so this section I call it with A2. Sorry, you already used. Okay, so this is A3, this is A4. So name it here B1, B2, B3, B4, C1, C2, C3, C4, D1, D2, D3, D4. Okay, so that's all about the section, and then we need to go into the table construction. Right, so this is your table. We have some item need to fill up. The first item is section. Okay, then CFM, then HF, FPM, size. Okay, section we have O, A. We write the main ducting first, A, B, B, C, and then CD. So this is your main ducting. Okay, and then the branch ducting. Okay, the green color here, A to A1, A to A2, okay, A to A3, A to A4, B to B1, B to B2, and etc. So here I write A to A1, A to A2, B to B1, B to B2, okay, C to C1, C to C2, D to D1, D to D2, okay, use this 1 and 2, and then you write for 3 and 4, A to A3, A to A4, and then we have a total of 2, 3, 4, 5, 6, 7, 8, 16 branch duct. All of the branch have 400 CFM. Okay, right, so the main duct we have only 4 section. Okay, OA1, AB2, BC3, CD, 4 section. Okay, so the CFM here goes from 6400 and then reduce to 4800, and then reduce to 3200, and then last one is 1600. But all of the branch ducting, we have 16, have a same CFM, which is 400 CFM. Okay, the HF basically is based on our criteria, which is HF over 100 equal to 0.1 inch water dot G. Okay, this is 100 feet. So if you have a different length, for example OA, we have length of 10 feet. Okay, here's 10 feet. But AB we have 10, which is 20 feet. So same goes with BC and CD. Okay, so here OA is 10 feet. This is 20, 20, 20. Okay, so to calculate HF, which is 0.1 over 100 multiply with the length of the section 10, so it becomes 0.1 over 100 becomes 0.01. Okay, it becomes 0.01. So just write 0.01. Okay, so here it becomes 0.1 over 100 multiply with the length of the section is 20, it becomes 0.02. So I just write up 0.02. This is also 0.02, this is same 0.02, and then this one, all of the section, okay, have a length of Okay, A to A1 is 10, and then the next section A1 to A2 is also sorry, is this is 10, 10, 10, 10. Okay, 20. Okay, it becomes 20. Okay, the length for the branch ducting from A to A1 is only 10 feet, but from A1 to A2 is 20 feet. Okay, so the total length for each of the section here, A1, A2, A3 and A4 is 10 plus 20 plus 10 plus 20. Total is 60. And then we have 4, so 60 multiplied with 4 section, we have 240. Okay, so here the total length is 60 multiplied with 4, and then this is the length, we multiply with 0.1 over 100 feet, so we get 0.24. Okay, so the total friction for branch ducting is 0.24. Right, so how about the FPM? Okay, FPM is the velocity for each of the section. Okay, first, in order to find the velocity, we need to refer to a chart. Okay, right, so this is the chart used to calculate find the relation between flow rate, velocity and also friction loss. So the y-axis is CFM and so x-axis is friction loss. Okay, so our first section just now, okay, okay, the CFM is 6400, HF is 0.1 per 100 feet, and then the FPM, okay, we want the FPM, right, so our HF is 0.1 per 100 feet. Okay, first we refer to our CFM 6400, goes here. So where is the point of intersection? You need to look at the x-axis, which is friction loss. Our friction loss per 100 feet. Okay, not for each section, but per 100 feet. So this is 0.1. We drag it into the y-axis. So the value should be here. Okay, so to get the value of FPM, okay, we need to go into the FPM axis. Okay, FPM axis, this is the axis, a little bit decline. So the value here correspond to 300, 400, 500, 600, 700, 800, 900, 1000, 1002, 1004, between 1004 to 1006. So we drag it into the axis. Okay, so the value is not too accurate because this is using the chart. Okay, so it estimated around 1500 CFM. So we put the value of 1500 into our table. Okay, and then I will fill up all of the section based on the value of CFM. Right, after we plot on the chart all of the value, okay, we got value and put into the table here. We got 1500, 1400, 1250, 1050, and for the branch ducting, because all of the ducting have a same CFM, so it should have the same flow rate, okay, which is 750 FPM. The next part is size of the ducting, which is we need to find the round ducting first. Okay. Okay, so for the same diagram, we need to find the ducting diameter here. Okay, for example, the first section here, OA 6400 CFM. So we need to plot into the ducting diameter. So it's around here. Okay, 28 inch. Okay, then can plot another 25 inch. Okay, and then do for the rest of the section. Okay, so I have filled up all of the section 28, 25, 22, 17, and also 10 inch if the ducting is round shape. So because the question requests to have a rectangular ducting, okay, so let's see our spec here. Right. Okay, the maximum height size of rectangular ducting is 20 inch. So it means that one side of the rectangular ducting, the height must be 12 inch. So we need to find another length of the rectangular ducting. We already have the value for round ducting, so we need to transform into the rectangular ducting. In order to do that, we need another chart. So okay, so this is the chart equivalent round ducting size. For example, the first section just now we have 28 inch. How to transfer into 12 inch, multiply with another size, another side. Okay, so from 28 and then into 20. Okay, so first we find the round ducting 28 here. Okay, make it bigger, and you need to fix one side to be 20. So I just put here 20. So all of the section must have 20 inch of its height. Okay, so for 28 diameter, inch diameter, we need to have another side to be around 25 inch. Okay, then you need to do for the rest of the section. Right, so after you have find all of the value for the side of rectangular ducting here, so we fill into the table here. We got the value 35, 26, 21, 12.5, 4.6. So this is the width of the rectangular ducting. So this is the last part, and in order to complete the table, we need to total up all of the friction here, HF. So 0.01, 0.02, we sum all of this, it will become right 0.31 inch water gauge, right? So that's all for the method to construct the air distribution table, and also design of the layout for air distribution system inside the air conditioning system. Thank you.